additively manufactured pistons for the most powerful Porsche 911, the GT2 RS. Enormous forces act on the components. To ensure that the printed pistons meet the high demands, comprehensive quality control is required. A unique, holistic inspection process by ZEISS, specially developed for additive manufacturing, uses the combined expertise of all ZEISS technologies. For Porsche, quality control is at the heart of this innovative production process.
This process resembles a welding process in that I build the component up layer by layer. And each layer can, of course, contain defects. That's why it's important to examine the components closely during or after the process, especially during prototyping, so that the parts can be put to the test with a clear conscience.
With the help of various imaging measurement methods, such as computer tomography, the scanning electron microscope, or tactile measuring, the additive manufacturing of the components is monitored. It is important to ensure that all the data is linked across the various measurements.
In the end, we will have a complete and combined quality assurance process for our project, which will then be able to merge the different partial results from the analysis and the process sections in order to obtain the information that is required to ensure the component quality.
Daraus dann die Information zu erhalten, die für die Absicherung der Bauteilqualität erforderlich ist.
The first and crucial quality control step takes place before production begins, namely with the starting material, the powder.
ZEISS correlative microscopy approach allows us to cross-validate data from light, electron, and X-ray microscopes, and by doing that, we are developing unique solutions to understand the impact of powder degradation and aging on powder recycling in additive manufacturing.
Once the powder is correct, the actual printing process begins. Layer by layer, the high-performance piston is created. After printing, the piston is shaped. Heat treatment and machining can change the dimensions, making it necessary to check them using a coordinate measuring machine or optical 3D digitization. The next quality inspection step uses a high-resolution X-ray CT to detect any cavities or material impurities in the structure. Particularly important for the highly strained pistons, the material inspection after printing.
Even once we control the additive manufacturing process to minimize distortions and defect density, we still need a proper microstructure to have the adequate mechanical properties. Grain structuring and phase assessment before and after post-processing is being used in order to define specific heat treatments for additive manufacturing.
In the next step, X-ray CT and a coordinate measuring machine are used to check the surface quality and dimensional accuracy. This is decisive for subsequent correct assembly. Crucial in all process steps and at the core of ZEISS quality management. All measurement data is collected, linked, and evaluated centrally. This creates an overall picture, and correlations between the individual steps in the manufacturing process become apparent.
Especially with this piston material, which has never been printed before, it was of course a challenge to generate the quality of the components, which we were able to do very well with the assistance of the ZEISS company, and were then able to authorize the pistons for long-term operation.
The result of the test bench test is convincing. All pistons survived the tough endurance runs without damage. This has already been taken into account in the event of serial production.
The quality control for a possible series production is already part of the holistic solution approach, which contains a whole series of sometimes completely new solution approaches in the quality control in the 3D printing technology. This is necessary because we aim to meet the economic and technical requirements in series production.
An innovative and flexible system that uses the concentrated expertise of all ZEISS technologies to produce additively manufactured parts at the highest level, from powder to high-performance pistons.